Hey there, space enthusiasts. Today, we've got an exciting discovery to share with you. Did you know that around 2 million years ago, Earth was a very different place? Our early human ancestors lived alongside saber-toothed tigers, mastodons, and enormous rodents. But here's the kicker. Earth might have been exposed to cold, harsh interstellar clouds. Scientists have long thought that ice ages happen for a bunch of reasons, like the planet's tilt and rotation, shifting tectonic plates, volcanic eruptions, and carbon dioxide levels in the atmosphere. But what if some of these drastic changes were also influenced by the sun's position in our galaxy? In a groundbreaking study published in Nature Astronomy, astrophysicist Merav Opher from Boston University discovered that about 2 million years ago, our solar system encountered a dense interstellar cloud. This cloud was so thick that it could have interfered with the sun's solar wind. Opher and her team believe this suggests that the sun's location in space might shape Earth's history more than we ever thought. So, what's the heliosphere? It's a protective plasma shield that extends far beyond Pluto, created by the constant flow of charged particles from the sun, known as solar wind. This giant bubble protects us from harmful radiation and galactic rays that could mess with our DNA. It's one of the reasons life on Earth evolved the way it did. But, according to Opher's research, this cold interstellar cloud compressed the heliosphere, briefly exposing Earth and the other planets to the raw interstellar medium. This paper is the first to quantitatively show there was an encounter between the sun and something outside of the solar system that would have affected Earth's climate, says Opher, an expert on the heliosphere. Her models have revolutionized our understanding of the heliosphere, suggesting it's shaped like a puffy croissant due to the solar wind pushing against the interstellar medium. Now, she's uncovering how the heliosphere and the sun's journey through space could impact Earth's atmospheric chemistry. Stars move, and now this paper shows not only that they move, but they encounter drastic changes, Opher explains. She first delved into this study during a fellowship at Harvard Radcliffe Institute. To investigate this phenomenon, Opher and her team look back in time using advanced computer models to visualize the sun's position 2 million years ago, along with the heliosphere and the rest of the solar system. They trace the path of the local ribbon of cold clouds, a string of large, dense, very cold clouds, mostly made of hydrogen atoms. Their simulations showed that a cloud named the local lynx of cold cloud could have collided with the heliosphere. If this happened, Earth would have been fully exposed to the interstellar medium, where gas and dust mix with leftover elements from exploded stars, like iron and plutonium. Normally, the heliosphere filters out most of these radioactive particles, but without this protection, they could easily reach Earth. The timing of this exposure matches geological evidence of increased 60 feet and 244 Pu isotopes found in oceans, the moon, Antarctic snow, and ice cores from that period. It also aligns with cooling period records. Harvard's A.V. Loeb, a co-author on the paper, adds, "It's exciting to discover that our passage through dense clouds a few million years ago could have exposed the Earth to a much larger flux of cosmic rays and hydrogen atoms. Our results open a new window into the relationship between the evolution of life on Earth and our cosmic neighborhood." Opher notes that the pressure from the local lynx of cold cloud could have blocked the heliosphere for anywhere from a few hundred to a million years. But once Earth moved away from the cloud, the heliosphere would have enveloped all the planets again, just like it does today. While it's impossible to know the exact impact these cold clouds had on Earth, like whether they triggered an ice age, Opher says the sun likely encountered other cold clouds in its billions of years of existence, and it's bound to stumble across more in the future. Opher and her team are now trying to trace where the sun was 7 million years ago, and even further back. This is possible thanks to data from the European Space Agency's Gaia mission, which is creating the largest 3D map of the galaxy, giving us an unprecedented look at how stars move. This cloud was indeed in our past, and if we crossed something that massive, we were exposed to the interstellar medium, Opher says. Her team at BU's Shield Drive Science Center is exploring how this exposure could have affected Earth's radiation, atmosphere, and climate. This is only the beginning, Opher says. She hopes this paper will spark more research into how our solar system's encounters with interstellar forces have shaped life on Earth. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell for notifications on our latest cosmic discoveries. See you next time.